Good afternoon, everyone. It's my pleasure to welcome Michael Bayer, a longtime speaker at PyCon and the creator of SQLAlchemy. He's going to be talking to us today about building apps, web apps in SQLAlchemy. Let's give him a big round of applause.
Hi. I want to thank Selena Deckelman and Jason Myers for doing great talks on SQLAlchemy and Alembic right before me, so we can hooray for them. It set me up to do the final talk for SQLAlchemy. So it is called, it's on the screen there. Oh, look at that, it's really big. Writing the app. What is this talk about? So this is about writing larger, longer-lived applications with relational databases and SQLAlchemy, and how SQLAlchemy deals with that kind of issue. The foundation is what we call the code that we write when we first plug in our foundation, our frameworks and libraries. So when you first start to write your app, before you begin writing your use cases, you have this thing that I call the foundation, like your data types that are special and other things to do with constraints and ORM patterns. I think that having a healthy amount, not too much, of upfront code is a good thing, rather than a failure of libraries and frameworks to do everything possible. SQLAlchemy is designed with being able to write these foundations in mind. So how do we define what a foundation is and is not? The foundation includes the technologies we're using, like we're using Flask or Pyramid, what libraries, frameworks, how we structure our directories, name our files, what kinds of architectural patterns we're going to be using, how we build it out, if we're using integrated testing, configuration. So the decisions we make when we do the foundation will determine when a new developer comes in the project, what is that developer going to need to understand in order to add new features to your project. And it will kind of determine exactly what it's like when you start with, hey, the customer wants this new feature. Where do we start? Where do we do the middle? And where do we end? So here the italics around is, or the foundation is, it's the source files at the base of our application. It's the basis for patterns and idioms that we're going to repeat throughout the app. It might be reusable in other applications. And it represents kind of the way that we've adapted the frameworks and libraries we're using to the task at hand. It's specific to what we're doing. So the foundation is not a replacement for frameworks or libraries. It's not the start of our company's new app platform. It's not like we're writing our own amazing system that we're going to publish. It's really meant to be specific to what you're getting done. It's about practicality versus trying to make some bigger thing. Not a reinvention of the wheel, unless the wheels you have are terrible. Pretty obvious, right? So let's see a foundation, and actually this slide is the plug for the Pyramid web framework. Woohoo! Because we don't have any Pyramid talks this year, and then we have 3 SQLAlchemy talks, which is great, but I feel guilty that we have so many talks and Pyramid has none. So I actually like Pyramid, and the sample app we have here is the Pyramid app. I like about Pyramid, I really love the view renderer model. Your view function has a little decorator that says this view will talk to this template, this kind of template. You can actually have several renderer decorators. I think that's really cool. I think it's opinionated in the right places. I like its emphasis on testability, attention to detail, and of course, when I work with Pyramid, nothing ever works, nothing ever breaks. Nothing ever does what you don't expect, because Pyramid's components are like super duper industrial rock solid, and I always trust them 100%, so which is really great. And Pyramid is, of course, curmudgeonly, like me. And then, of course, you don't have to use Pyramid. If you can write a foundation in any framework, meaning you could also use Flask. All right. So this is the link that I just made public on Bitbucket, and hopefully that worked. So if you want to go, so basically this talk, if you want to go to this application, everything I'm talking about is going to be in this app, and you can download the app, and you can run it and play with it, and I'm going to have it up on the SQLAlchemy site as kind of like the beginning of actually having sample apps. Like the Pyramid tutorial has a sample app, and this will be another one. So I'm going to go to the next slide. If you just go to my Bitbucket Zeek, you guys know the Zeek name, right? Okay. So an overview of what I'm going to try to cover, the meta folder, conventions and recipes, session scoping, which is the part that makes me nervous to talk about, constraint naming, a little bit on migrations, not too much, and then some thoughts I have on testing. The meta folder is something that I got from first working with pylons. When pylons would build out a project, they'd have this file called meta.py, and I actually break it out into several files. And I just, from the minute I write the app, I know there's going to be a meta folder, which will have the foundation. It'll have various files that are going to deal with the kinds of things I know that my app needs to worry about. So the name of the app is ATMcraft, and there'll be like a model folder. And then inside of model, the first thing I put there is meta, which is where we're going to deal with database stuff in the abstract. In there, we have init.py, which provides names to import from the outside. Base py is fundamental units like your session, your declarative base, object relational mapping helpers, schema generation and definition helpers, and then things to do with special data types. So the first part is conventions / recipes. I can't quite figure out the difference between a convention or a recipe, so they're kind of interchangeable. The goal of a convention / recipe is to reduce as much repetition as possible in day-to-day code without taking it too far. Things we use for recipes are Python functions, Mixins, SQLAlchemy events, compiles, recipes, custom types. SQLAlchemy is really oriented towards this kind of programming and constantly trying to make this system work better and more predictably. It wasn't there in version 1 or 2, but as we've gotten through version 7, 8, 9, it's getting more and more mature and predictable. Some recipes, conventions become SQLAlchemy features. Lots of them do. Why aren't these conventions and recipes part of SQLAlchemy to start with? Well, one place that we often draw the line is with naming things. SQLAlchemy really doesn't ever want to name anything. It doesn't want to name your tables or your columns or your constraints. So things to do with naming are typically not out of the box. You've got to come up with some way to come up with names. Some conventions do become features, or at least partially. The project tries to, we like features, but we like to start with making something as a composable set of components that you can kind of build, mix and match different things out of them, rather than just a flag, like do this. We'd rather you come up with a recipe for like do this thing, or maybe this, or someone else could adapt it to do that. We think that's more flexible and open-ended. And the philosophy here is if you, the famous proverb, give someone a fish and feed them for a day, or give someone an event listens for fish available hook, and then you can fish for all the applications you want, or something like that. More jokes to come. This is a really, really simple convention that I actually use. There are more complicated versions of this that are more flexible, but this is a simple one. You want all of your classes to have a primary key that's an integer, surrogate ID. SQLAlchemy with declarative lets you make a Mixin class that has ID. So any class that you apply surrogate PK to here will have an ID column. And then any class that wants to refer to another surrogate PK can have a function, you'll see in a second how they use this, called reference call that will make another column with a foreign key that points to your ID column. And this is very obviously kind of hard-coded. There's more flexible versions that are actually in the app. If you do this surrogate PK reference call thing, it looks like this. So you might have a class, called count balance that subclasses your declarative base and the surrogate PK, and it has a table name, and then you have a reference call to another table called balance type. And then, as a lot of you might know, SQLAlchemy has the relationships by default separate from the foreign keys. So we have balance type is a relationship to the balance type class. So this is a little bit better than having explicit ID equals column, integer, primary key equals true, balance type ID equals column, foreign key, balance type. It's a little less verbose. It's a little more repeatable and less things to type, and more importantly, less things to change if you want to change how you do things. This is a really, really simple, quick and dirty pattern. The example app has this pattern, which is, the implementation is a little bit more complicated, so I didn't want to put it on a slide. But this is the, elusive many-to-one relationship. So what many-to-one does is a function that does basically what you see here, which does basically what you see here. So, and I wrote a blog post about this years ago, that SQLAlchemy, I called it Magic, a new ORM, and it really wasn't a new ORM. It was just using recipes on top of SQLAlchemy to make it less verbose and come up with recipes that work for your use case at hand. And actually, the many-to-one, one-to-many, I've come up with a recipe now that's so cool that I probably will add it to SQLAlchemy, but you get the point, is that you can, if you think SQLAlchemy is verbose, you should try to come up with patterns to kind of reduce how much typing based on the app at hand. Another example of conventions are when your database, you're targeting more than one database, or you're targeting just one database, and they have some kind of SQL function that you want to just have a Python object that represents it. Like, I often want to do the current time on a database, but in UTC. And if I'm targeting Postgres and SQL Server, they have completely different functions that do this. And Postgres has, as far as I know, you have to do this whole current timestamp at time zone UTC stuff. So if you have things like this with your database, you can make your own little quick ad hoc functions and use the SQLAlchemy compiler extension, which is documented on the site, to come up with little functional things like this, so that when you use the UTC now function, it will resolve to the current timestamp at time zone on Postgres. It will resolve to get UTC date on SQL Server. And then if other databases are available, by default it'll raise, and then you have to implement how that would be done for other databases too. UTC now is another function that maybe we should add to SQLAlchemy because it's pretty common. But the concept here is if you have some other weird function you're using, you can use that as well. Using that recipe, we can execute a select statement, select UTC now. We can use UTC now as the default in a column. So like created at means that every time a row is inserted into orders, you'll get a default timestamp in created at. And then another way to do conventions is with events. When you build up SQLAlchemy metadata, you attach the table and columns and metadata things together. As those things are connected together, SQLAlchemy emits events that you can intercept and do things when they happen. The most useful in that regard is after parent attach. It happens when you connect a column to a table or a table to a metadata and constraints to a table, things like that. This recipe will add columns to all the tables that will store the created at time for a row and the updated at time for a row. And this is a way that instead of having all your tables have these columns explicitly, you can use an event and just stick them on as each table gets created. So that's a recipe. Custom types. Everyone, well, not everyone, but a lot of people use custom types. They're very handy for when you have some kind of special Python behavior to take effect for a value that's going to the database. And often I'll use this one, the bcrypt password type. As data goes out to the database, it is run through bcrypt first. As data comes back from the database, it is wrapped with a wrapper class called password that will do comparisons using bcrypt. So you can try this out in the app as well. And if you want to see what this thing looks like, it means you can kind of add rows to the database without dealing with bcrypt at all. You just put your secret, I'm a secret, and it will insert as a bcrypted value. And then when you query for a client record that has the identifier that we want, Snowflake in this case, we can just compare the secret field, which is actually the bcrypted version. You can't read it. It's not plain text at all. The plain text is gone. To a plain text password. The equality comparison here will actually run the I'm a secret token through bcrypt before doing the comparison. So using a SQLAlchemy custom type and a little ingenuity, you can have this transparent encryption of passwords, one-way encryption. So that's the end of recipes and conventions. There's more in the sample app to be looked at. And then the part which is more concerning to me is session scoping, because I'm just always trying to get people to understand session scoping, and it's just really hard to do. So the SQLAlchemy object relational mapper defines access through a central object known as the session. And when we write a web application, there's two things we need to really worry about with the session. Where do we get it when we handle a request? And when the request is over, where does it go? And also, how do we initialize it in the first place? So there's a lot of ways to do this. I'm going to show 3 patterns for how to get the session during a request. The method that most people are very familiar with and everyone uses is called the scope session. The scope session is basically a wrapper around a Python thread local, which means that when you talk to scope session and you say, hey, Mr. Scope session, can I have a session, please? It will consult a Python thread local variable and return for you a session object that is specific to the current thread. If you're in a different thread, you'll get a different session. And that's really all it does. And this assumes that the web framework you're using is going to basically have one request per thread at a time, meaning it won't work if you're using like Tornado, where you have multiple requests in one thread that are mixed up. So if your web system keys requests to threads, you can use the scope session and just have a session that's local to the thread, and that will work fine. And this is very common, and I use this, and everyone uses this. It's very common. Another variant on that is you can also use scope session not using a thread local, at least not directly. You can send to scope session a function called the scope func, which is a function that will give the scope session registry some kind of token it can use to key to get the current session. So with Pyramid, you can use a function that they provide called getCurrentRequest, which it was still using a thread local, but not within SQLAlchemy, using it within Pyramid, which, by the way, they hate thread locals, but this will work. You can say from Pyramid thread local, import getCurrentRequest. Please give me the request for the current thread, and then please give me the session that's scoped to that request. So you can do this too, and have Pyramid do the thread local stuff instead of you. And if you had a web framework that didn't have a thread local request model, this would also work. Like if you had a Tornado function called getCurrentRequest, you could use scope session with Tornado, and this would probably work, although I haven't tried it. And then the third method is don't use scope session at all. Don't do any kind of global stuff like that. You know, when you work with Pyramid, there's always a request object. Let's just put the session directly onto the Pyramid request as an attribute, because everything we do in our app already has the request. Let's just get the session from there. And then there's no more thread local anything, and then you are on the good side of Chris McDonough's temper. So you can say in Pyramid, they have an event called new request. It gets fired every time there's a new request. So hey, Pyramid, every time there's a new request, let's create a new SQLAlchemy session and stick it onto your request, and that's it. That's how it works. So you can do that too. I like the thread local thing because I don't feel like being required to have the request everywhere all the time, but suit yourself. So after those 3 methods of acquiring the session, how do we get rid of the session at the end? Every web framework has some kind of hook at the end of a request to clean things up. This is in the SQLAlchemy docs. I think everyone knows it. When your request is over, do a finished callback that will call session .close or scope session.remove. Everyone should, be aware of this. It's in the docs. It's like kind of Web Framework 101. And that's the end of the terrible session scoping section. Because it's just, I think it's really simple, and it's just, wow, people have so much problems with that. Constraint naming, some new features in SQLAlchemy. Database constraints like foreign keys, indexes, uniques, etc. have names so that you can target them in your migration scripts when you want to create new ones or drop existing ones and change what they have. Controlling these names, like having all your constraints named explicitly, is a good idea, but it's very tedious to do manually. And SQLAlchemy, as you know, doesn't provide any names because SQLAlchemy doesn't want to do names. It doesn't want to tell your DBAs, your grumpy DBAs, what to name their stuff. So SQLAlchemy wants you to do it, but it doesn't want you to have a hard time. It'll give you easier ways to do it. We can make names automatically using schema events, specifically that after DDL attach thing, after parent attach event I showed you earlier. However, SQLAlchemy has now made, there's a very common convention to use events to create names for your constraints and other things. We've added a new feature called naming convention, which allows you to set up a naming convention up front with your metadata, and that will do the event thing for you. So now in SQLAlchemy 092, -094, meaning we fixed the bugs with it as of 094, most of the bugs. You can make up this little dictionary with your metadata that has a bunch of string templates that will apply names to a lot of the common constraint objects like primary key, foreign key, uniques, checks, and indexes. So when you use a convention like this one here, and you can read the docs for how it works, your create tables will look like this, where you get all this handy, you can see all the constraints are named explicitly, and so when you write your Alembic migrations, everything that you want to target has a name. If you want to drop a primary key and recreate it, you know the name. The name isn't the weird auto-generated name that your backend database might do. And if you're switching between different backends, different databases have different naming conventions built in, so this is a way to override them. Does that make sense? Good. If you're using Alembic, this is a really squeaky stage. Can you hear that? It's really squeaky. Generating Alembic migration. We just had a great talk on Alembic migration, so I'm sure you all know Alembic fully now. Create Alembic meaning, what we're doing here is if you can basically have Alembic look at your database as it exists right now and look at your class metadata as it exists, and it will compare them. And it will generate a new migration script based on the diff of those things. This is a pretty, it works well, but not perfectly. We want you to modify this. We want you to check the script. It's not perfect by any means. But this now, if you get the latest Alembic and SQLAlchemy 094, it integrates with the naming convention feature very nicely so that you'll get a migration script with those naming conventions explicitly written out in your migration. So the only point here is that Alembic now integrates with the naming convention feature in a better way than it did before. Upcoming features for Alembic, and Selena talked about this a little bit, multiple version directories, automatic branch resolution, kind of like a merge, and it's actually pretty easy to do. The versions of Alembic right now are a linear list, so it's like version A, version B, version C, and it's a straight linked list. And now it's going to be, well, when we do the feature, it'll be more of a directed graph where any version file can have any number of parents. And that's Alembic, okay? And we're on to the lightning round, which is testing. And I've come up with some interesting things about testing that I want to show you. So, for testing database-enabled models, there's two approaches now. There's one approach that we've done for a long time, which is the transactional approach. That's in the SQLAlchemy docs. And recently, on the job, I had a client who wanted to do a lot of tests that are against their model classes, but they wanted to be able to run them without there being a database available. So I worked up a new system, which is called the mock approach. And I think the mock approach is really neat. It's a little more tedious, but it's kind of cool. And maybe next year I'll think mock is awesome. I think right now it's interesting. So so basically the goal of testing here is we want to be able to test our model classes, and the model classes really need to be able to query against the database to do things. How do we test those classes? So in the transactional model, this is in our documentation. What we do is we basically have the test run in a database transaction, and when the test is complete and tears down, the transaction is rolled back. Anything that happens within the test, so the test can freely read and write from the database, but everything it does is then rolled back so that the test ultimately had no effect on the database. So the simplified structure for that is that in your setup, you want to make a connection to your database, you want to begin a transaction, and then you want to bind the session that you're using for your test to that connection that is now open in a transaction. The way SQLAlchemy does transactions is that session will say, hey, I'm a session, I have a new connection, I'm going to do some work too, and begin a transaction, and then commit my transaction. When session goes to commit the transaction, it won't actually commit because it's part of a broader context that is scoped outside of the lifespan of that session. And this was written this way very intentionally to support this kind of pattern where you can nest transactional containers. So in this test, in the fixture, we want to basically just add data to the database freely. Just add whatever you want to test against. And then in your test, you can query the database freely and just do your test. And then if your session wants to commit data, it's fine. If your session wants to do a rollback, that can be done as well. I actually worked that out with someone on Twitter. This example will not do that, but there is a way to add more events and more complexity such that if your unit test wants to also roll things back on the session without the enclosing transaction being affected, that can be done as well with a little more work. And then when the test is over, we close the session, we roll back the transaction, then we close the connection, returning it to the connection pool. This is kind of seem familiar at least? All right. Everyone here, only one person has to say yeah, and then I'm like, good, great. In practice, it looks kind of like this. You'll have a fixture that's going to create model objects, and then in your test, you'll be basically calling upon the fixture to get the data set up that you need, and then you'll, in this case, we're testing a pyramid view. Pyramid has this awesome object called a dummy request. I love it. You make a dummy request, you put whatever you need into it, and then here we're asserting that this request raises a 403 error code based on the token that's been timed out, so it's kind of been gamed to work in that way. So transactional testing. The advantages of transactional testing. It's easy. I think it's easy. I think it's well suited towards integration tests. Integration tests meaning you're testing kind of a broader scope of functionality all the way from your view all the way back to the database and back up again. It's kind of your whole stack is happening. It's really not as much of a unit test. Disadvantages are that it could be slow because you're doing a lot of database setup and teardown. The test might be too generalized. You might want to test you might not want to have all the database stuff happening within your test as well. And you need a database. So that's transactional testing. So the other kind of testing is mock testing. And if you're in the Bitbucket repo, this file, mock session py, shows basically what looks like a SQLAlchemy session, but really this module uses almost no SQLAlchemy at all. It uses the Python mock library. I was talking to Michael Fjord on Twitter. He's the author of the Python mock library. I really love the Python mock library. I give it 2 thumbs up. And this thing basically is 99% out-of-the-box mock with a couple of little twists to make it such that you can set up fake SQLAlchemy queries that are parameterized, meaning the different parameters you give it, you can assign different return values to the mock. How many people here are familiar with using mocks for testing in general? Just the idea that you have this mock which kind of acts like something, but it's not really that something. It's just actually it's an imposter. It's like, I'm only pretending to be the thing you think I am. So this thing is not a SQLAlchemy session at all. It's strictly just a mock. But as you might be able to see here, we can have different queries and plug them in with return values that are different. And we can even plug in a side effect of no result found. And then later, when you go to query, the calling code is assumed. You have to basically build up these queries to be exactly what the calling code will be calling upon, which is one of the reasons it's difficult. And it'll get back data that looks just like it was hitting the database as you tell it. So the simplified structure of mock testing is super duper crazy easy. There's no transaction, there's no connect, there's nothing. You just get a mock session and the setup, and that's it. And you maybe plug your mock session into your scope session, depending on it depends on what session scoping pattern you're using. The fixture is just set up the mock session with some pre-canned fake results. And then the test is call upon the fixture and then call a query as you need, and you get the object back. So that looks very easy, but in practice, it's actually, I have found it is more difficult because you have to basically go into the code that you're testing and look at all the queries that it's doing, and you have to replicate every query it needs perfectly so that you can anticipate what queries the function is going to call, how they're going to look, and what kind of return value. So here, this whole screen is just the fixture part, which before was just like one row, one line, insert a record and commit it, and you're done. Here we have to kind of anticipate what the queries look like, right? Does that make sense, why I would need to do that? So you can see, and this is, and the fixtures that are in the sample app, go look at them, you can see they get a little, it was just more tedious to write these fixtures. But the end result is you can still write, the test usually looks exactly the same, and even nicer, sometimes you can look into the mock and make sure certain things were called as you expect. So the tests themselves look exactly the same or better. So that's the mock system, and I found it to be very interesting. Once I got that mock session to work, I was really like, wow, this is kind of a mind blower. But I'm still not sure. Advantages to mock testing are that there's no database needed. Tests can be focused to smaller units because less of an integration. And of course, it encourages your code to be modular because now we've got to write these mocks that are matching all the SQL functions. You really have to be on top of how your code is organized such that it's feasible to be mocked. And it's fast. There's no setup or teardown, really. Disadvantages to mocking is that the fixtures are really tedious to create. It won't actually catch problems with your ORM if your SQLAlchemy ORM isn't configured correctly or your SQL queries aren't right. It will not actually catch that at all. So you're testing less. And then this is a problem with mocking in general. I think people have done talks about this much better than me. If you do too much mocking, you kind of end up writing a mirror of the code that you're testing in the first place. So sometimes your mocked out tests can end up just being tests that the code does what you told it to do, even though it's still the incorrect thing. The mock won't actually know that. So that's kind of a mocking issue. And then, for the final round, we can look a little. The example app is, I gave you the link, and we have to put I have to send them the PDF of this so you can get them online and stuff. What I will do is, so for the source code, you can go up to Bitbucket and look at the source code. Please download it. And what we'll do here is we'll run the Pyramid app and run the quote-unquote client. And here comes the part where this will be great if it works, which it should. So I have the Pyramid app running in this window. So it's just serving it's actually a web service that acts like a miniature ATM machine for a bank. So you can send deposits of money into it, and it'll basically store your account information, how much money you've put in, and then you can make a withdrawal. You can withdraw money from different quote-unquote accounts. And it has maybe 5 or 6 tables. And it's a cute little app. And then over here is a Java app that is actually going to be the client. In this Java app, you'll see in a minute what it does. This Java app is actually a client for the Pyramid app, but it is also a server for the client that I'm going to run. And I don't know how much you can see. So this should be awesome if it works. So this client is a program called Minecraft. This is also known as the gag at the end of the talk. So like if the talk was terrible, well, at least he did that silly gag at the end. No, but it's cool. So, and it's nighttime, okay. So you guys can see the screen, right? Fortunately, our ATM machine is open 24 hours. Yep, and that is the Zeke. There's a chicken in my bank. Okay. So the idea here, and what you want to do is kind of watch the blue at the. Can you guys see the terminal on the side there? Yeah. In Minecraft, ATM machines are actually in the form of chests. So if I hit the chest, it actually made a web service call back to the Pyramid app, and what it did was it has an auth token that's for my session. So basically, this chest being open is like an open session to the server. And the first thing that the ATMcraft app wanted to say is, oh, you have 6 diamonds and 6 lapis blocks. So those are Minecraft block codes. So there's my inventory, and I can actually take 3 diamonds out. I can make a withdrawal, move them down. I put them here. You can see something just happened, and it basically said, I withdrew 3 diamonds, and you can see over here, there's a withdraw call to the web service. And I can, my lapis blocks are going to take some stone, put the stone in the bank, so I may deposit the stone. And if you look at the terminal, so basically, that's what it does. It's an ATM machine.
So if anyone has questions for Mike, they can come on up. I'm going to use my powers for evil and ask the first question. You were talking about session scoping, the thing that you didn't want to talk about, so I apologize for going back to it. But one thing that I've encountered a few times in problems I'm trying to solve is the idea of a long conversation where, over multiple requests, you want to maintain the same open session if you're manipulating a complex object that you want to do an undo or something. Are there any conventions that you would recommend using SQLAlchemy for that, or is it more about roll your own?
Is it a long transaction, or the question was the question is yeah, so is it a long transaction that you're running? Yeah,
like let's say you have somebody who's making multiple AJAX requests because they're editing a complex object in their browser, and you just want to be able to roll back.
Well, if it's in the browser, the HTTP request is stateless, so you wouldn't have the transaction open between requests. So, I mean, there's different ways to do it. I would use a different session for each request and just kind of resuscitate the state that you need each time.
Okay.
I wouldn't try to get too fancy with it. That would be my advice.
Thank you.
Yeah.
Is it possible to get the transactional rollbacks working with SQLite? I attempted that for a while and didn't.
Do you mean like DDL rollbacks, or
nested transactions and rolling back with SQLite for?
Okay, so nested. Do you mean save points?
Yeah, I guess so.
They should work in SQLite.
Okay.
Save points, I believe, are working.
Okay.
Yeah.
I had a question if you'd seen the talk, Stop Mocking, Start Testing, from, I believe, 2 years ago at this convention. What were your opinions on that, especially with now this new mocking stuff and everything else? I was just interested in your thoughts.
Well, I didn't see the Stop Mocking, Start Testing, but I knew the idea was kind of some of the things I was getting at, right? Yeah, I mean, those were my thoughts, is that mocking, I think it's really cool. I've kind of been bitten by the mocking bug, but I have yet to get bit by that bug, painfully. So yeah, I know there's caveats. But I haven't been mocking at all, so I'm kind of swinging from one side to the other. Okay. Yeah.
Hi. I was wondering if you thought about making a pyramid scaffold out of ATM craft.
Okay. If I knew what a pyramid scaffold was, then I could do that.
It's the template thing where you can just press the
like
button
you
and
do a
you
thing.
have
Yeah,
good
you know what?
conventions.
So it's like a pre-packaged template. Yeah, I think that would be a good idea. We should have people look at what I did and make sure I did. I mean, it should use some more. The way the ATM craft was written was very, very simplistically. It doesn't use the ZOP transaction stuff, which you probably should use. So it probably needs a little more stuff in it. But yeah, I think that would be great. Yeah.
I've got one more, sorry.
Sure.
One of the initial things that attracted me to SQLAlchemy coming from Hibernate was the ability to just use table mapping so that I could have my model objects be just plain old Python objects without having to inherit from some magical base class. And then instead of mocking out sessions, I'd be able to abstract my data access through a repository or something. How do you feel about that? I've not seen that much in my peers. I was just curious what you...
Well, SQLAlchemy started out very inspired by Hibernate. And for the first 3 or 4 versions, we didn't have declarative. We had just map, like your classes were POJOs, popos, sorry. And then you have the table, then you had the mapper. And I just found when I actually went to try to use that system, it was really tedious. Some people do work that way. But it just seems like from a pragmatic point of view, it just works out more easily to have your classes and tables somewhat. I'll sometimes use a certain style, which is in the docs, which is where you have your class laid out, but instead of having the table columns inline, there'll be an inner attribute underscore table pointing to a completed table by itself. So I'll sometimes do more of a hybrid approach. But the separate, I mean, when I work with Hibernate, having those XML files was really just too much. It's hard. So yeah, I don't have a golden rule there, which is why SQLAlchemy is always so agnostic about everything, because I really want it to be kind of open-ended.
Thank you.
Yep.
If there aren't any other questions, you can sync up with Mike after the talk, but thank you very much, Mike.
All right.